I am trying to work on a new feature. Basically, what I want to do is get more results when I do a search. So for example, if I search for San Francisco, as you can see, I only get 10 results. And this is because Strava, the API only returns the top 10 results. In order to return more results, I need to submit more requests. And I'm going to try to use Claude to help me do this. So maybe I'll tell Claude to look into my current code base to understand the context, and then I'll try to prompt it to see if we can make updates. Can you look into the code, specifically the search endpoint in activity API.py to understand how it works? Then could you come up with a plan to fetch more results from Strava by dividing the bound into 4 sections? Okay, so it came up with a plan. Let's review it. So here's how it currently works and the plan. So current flow, geocode location, latitude, longitude, yep. And then get bounds computes a square boundary box using radius times square root to the corners. Check cache, okay, and then makes one explore segments call to Strava. Max 10 segments returned. And then number 5, we will cache and return the results. The problem, Strava caps explore segments at 10 results per bounding box. So my plan is to split into 4 quadrants. Given the full box with southwest and northeast, compute the midpoint and split into 4 sub boxes. Okay, so we have 4 boxes here: southwest, southeast, northwest, and northeast. Okay, so these are basically 2 corners of each quadrant, if I understand this correctly. Change needed, utils.py, add split boundary, list, segment boundary, sigma, then return 4 quadrant boundaries. Okay, API.py, search, replace the single explore segment call with a loop over the 4 quadrants, collecting and deduplicating by segment ID. Okay, and then cache, no change needed. Cache key is still based on the full bounding box, and the combined deduplicated result is stored as before. Okay, this gives you 40 segments instead of 10. So yeah, I think this is pretty good. I think the only thing I might want it to change maybe in the future is instead of looping over the 4 quadrants, maybe I probably will prompt it to use some sort of thread so that it can loop over 4 quadrants at the same time. This way it can reduce the response time. And then the cache right now is caching on the original bound, but maybe it could be better to cache on the smaller bounds to try to reduce the number of requests needed to fetch to Strava. And then once this works, then maybe I'll try to prompt it to try to improve it. Okay, what did I just do? This sounds good. Please implement. Okay, let's see. So I already made updates. So created a split bound function, takes in the segment bound, calculates the midpoint, returns 4 segment bound schema. And the segment bound schema is basically a object that will hold the latitude and longitude of 2 corners that's needed in order to submit to Strava API. Okay, I think this is good. So I'm just gonna do yes. Let's see what else here. Okay, so we removed the original API call to explore segments. In the for loop, we basically will call the explore segments function to fetch data from Strava. And let's see, what is this? And then this is try to reduce the duplicate. Okay. Explore segments.append. I think this looks good. Done. Here's the summary of the change. Okay, cache behavior is unchanged. Okay, cool. Now let's give this a test. So since I'm gonna hit search again, this is not gonna work since this radius it's already cached. So I'm gonna try to do something else. I'm gonna do here. So it's gonna take a lot longer since we are making 4 different calls. And okay, yeah, there we go. Now we got more results. Now we have maximum of 40 results in here, which is great. Sweet. So yeah, so basically, Claude was able to do exactly what I wanted to do just from a few prompts, which is great. And let's see if the cache works. So if I hit search again, this should be instantaneous. Cool. Okay, so I think next, instead of caching by the original bound, I think I want to try to improve this so that it can cache, by the smaller boundaries. But before I'm gonna make any changes, I am going to commit this so that I don't lose the work. Okay, so next I'm gonna try to prompt the AI to try to improve the caching logic. So basically, to just quickly go over what I'm trying to do on the caching logic. And right now the caching logic basically is cached using the coordinates in these two corners. Okay, I want to create a cache based on the smaller boundaries. So for each boundary box, I would just get the two corners and cache that. Instead of caching by the original bound box, can you create a plan to cache by the split bound box? This way, it can reduce number of requests to Strava if there are overlaps. Let's see what Claude thinks. Okay, so and current flow checks cache for full bound box, full hit or full miss. On miss, fetch all 4 quadrants, combine, cache the whole result under the full box key. Problem: if two different searches produce overlapping quadrants, example, nearby locations with similar radius, the full box cache never hit because the key differs and all 4 Strava calls are repeated. So here's the proposed plan. Remove the full box cache check entirely. Instead, move caching into the quadrant loop. Split bounds into 4 quadrants. And then for each quadrant, check cache by the quadrant's own boundary key. If cached, use cache data, skip Strava call. If not cached, fetch from Strava, cache that quadrant's result individually. Combine all 4 results and deduplicated by ID. Return combined results. No full box cache right. Yeah, that sounds pretty good to me. Okay, the change needed in the search function, remove the get cache segment and set cache segment calls around the full box. Inside the quadrant loop, call these 2 functions per quadrant, and then in the utils.py, no changes needed. Okay, cool. Yeah, and I feel like Claude can explain this way better than I can. Why this is better? 2 searches with different radius or slightly offset centers can share quadrants if they're normalized bound round to the same cache key, and each cached quadrant is reused independently. Yes. Okay. So it removed the cache. So it removed some code and then removed that. Okay. So it basically moved the cached segments inside the for loop, right? And then making sure that it checks the cache first. Yeah, it checks the cache first. So if there's cache data, then we get it from the, let's see. So for each quadrant, we will get the cached data and the cache key. Oh yeah, and then we would try to deduplicate the cached data. And if there is no cache data, then we call the API endpoint. And from there, let's see, for each segment, try to deduplicate the data here. And then we will set the cache key. Okay. Well, yeah, this looks about right. So I am just going to okay this and then test it out. Let's see. Okay. So there's more changes. Export segments. So we removed that. And then we renamed it to be all segments. Okay. Append stuff to all segments. Okay. If source is cached, return this source. Okay. Let's see. Okay. This looks good. Okay. Cool. So here's what's new. Each quadrant is cached independently. There's a new variable called all segment, which is a list of dictionaries. And then source is cached. Only all 4 quadrants were cached hits. Otherwise, we call Strava. Okay, so source is cached only if all 4 quadrants were cache hits. Otherwise, Strava. Okay, that makes sense. Deduplication still happens across all 4 quadrants via CMIDs. Okay, let's see what this will look like now. Okay, I'm gonna do. I'll try to do Los Angeles. Let's do 25 again. It's gonna take a little bit. Okay, I see some results. I see more results. And so if I hit search again, should be the same result, but it should be cached. There we go. That was instantaneous. That was good. So now my question is, how do we test whether if things are overlapped? And I feel like since I'm not allowing decimal values here, I don't think this could be tested. So it's going to be hard to tell if it's cached or not. So one thing I can do is maybe for the source, I can add a new source called partially cached. You add a new source called partially cached, or name it how you think it will fit. I want to know if the result is partially cached. Let's see. Remove the source cached. Remove that. Cache count. Okay. If cache count is 4, source is cached. Cache count is 0, Strava. And then otherwise, partially. Looks good to me. Okay. Let's try this again. So this is a 24-mile radius. This is cached. Now I'm going to move it to 23. And I believe it's this one here. Strava, cached. Okay. Yeah, this is going to be a little bit hard to test out. Let me try one more time. 22. Okay, Strava, C21. I'm going to try maybe something within 6. Strava, 5. Strava. Okay, yeah, okay. I think I actually won't be able to do the partial cache in my current code. And the reason is because right now my cache key is rounded to 2 decimal values. Okay, so the precision is 2 decimal values. And according to Claude, I think you saw it earlier, 2 decimal rounding means it's 1.1 kilometers. However, my search bar doesn't allow searches that's less than a mile. Therefore, I don't think the new cache key will work in this scenario unless I change this logic so that it allows you to search up decimal values as well. I think the next thing that I want to try to do is to try to make this a little bit faster, because right now the response is pretty slow since it's doing 4 different sequential fetches, and I want to see if I can improve it by using threads or make it just asynchronous in Python. So okay, can you improve the response time by making calls to Strava async so that all 4 calls can do it at the same time? Okay, let's see. So yeah, it's using the library called ThreadPoolExecutor. And then this will run only the Strava calls for cache miss in parallel, then combine it. Okay, this will make sense. Let's see. Okay, so I think it created a new function called fetch from Strava. It created an inner function, which I'm okay with that. Okay, so here is quadrants. So we have split bounds. Okay, then check the cache first and then fetch from Strava. Okay, let's see if miss indices. Okay, so right here we're checking. Oh, I see. We're checking which quadrant missed the which quadrant the cache miss. From there, we will start a thread pool for the missed quadrants. Okay, so basically this is just starting the thread pool, and then cache count length of the quadrant minus the miss indices. Okay, that makes sense. Okay, for the cache result, we're trying to deduplicate again. Okay, let's see. Let me just see. Future the result. Okay, there we go. This is where we combine all the data right here. Okay, I'm gonna okay this. Let's see where it goes. All right, all 4 cache checks run sequentially. Only the cache miss are fetched from Strava in parallel. So, okay, so all 4 cache checks run sequentially. Only the cache misses are fetched from Strava in parallel using thread pool. And the results are reassembled in quadrant order, deduplicated and returned. So if 2 quadrants are cached and 2 are misses, only 2 Strava calls are made and they run simultaneously instead of sequentially. Okay, this makes sense. I'm gonna go back to here. I'm just gonna refresh it real quick. Let's see. Let's go somewhere that we haven't tested out yet. I'm just gonna do Los Angeles again. Search. Okay, so that was pretty fast. Okay, that was actually really fast, which is good. And then if we look at the results here, this is Strava. That's just making sure the cache worked. Go to the next one, and the source is cache. So that worked. So yeah, so right now it's able to use the thread pool to basically run the fetches simultaneously. One thing I'm actually kind of curious is how many threads can I actually run, like maximum. So I want to understand how the thread pool works. How many threads can I run sequentially? Say if I break the bound box into 100 different bound boxes, Can I just run 100? Can I just start 100 thread pulls? I know it has to depend on your machine, but I just don't know too much details on it. So hopefully Claude can give me a decent answer. A few clarifications on terminology first. You mean concurrently, not sequentially. I meant concurrently. How ThreadPoolExecutor works. Let's see. Max worker equals to n creates a pool of n threads. If you submit 100 tasks to a pool of 4 workers, 4 run at a time. See, the rest queue up and wait for a free worker. Maximum workers equals to 4. 100 tasks submitted. I see. Okay. Can you start 100 threads for 100 bounded boxes? Technically, yes, but there are 2 limitation factors. Your machine makes sense. Threads aren't free. Each has memory overhead. 100 threads is fine. 10,000 threads starts hurting. Strava's rate limiting. This is the real constraint. Strava caps you at 100 requests per 50 minutes. Okay. So I think maybe one more thing I still want to find out is maybe I just look at the code. Let's look at the activity API, search, fetch from Strava, see how many workers we're starting here. Oh, max workers. It's missed indices. I see. Okay, so I guess the answer is, how do I know my machine can handle 4 workers? These threads are input and output bound, not CPU bound. Each thread spends 95% of its time just waiting for Strava server to respond. During that wait, the thread is idle and uses essentially no CPU. Okay, waiting for Strava to respond 300 milliseconds. Process 1 millisecond. Oh, thread 2 waiting for the response. I see. All 4s are waiting simultaneously, no CPU content. Rule of thumb, CPU bound tasks workers should equal to the number of CPU cores. Input and output bounds workers can be much higher than the core count because the CPU is mostly idle. You can check your core with mproc, but for 4 HTTP request thread, even a single core machine handles it fine. The bottleneck is always Strava. Okay, this makes sense. Let's see if I have the mproc. Oh, okay. So I have 12. I think that means I have 12 cores. So that means I can handle a lot more in this case. Cool. Yeah, I think that's the feature that I want to do, and that's pretty much it. So next I am gonna try to deploy this. So once I deploy this, then this should show up in the live site. And hopefully by the time you watch this video, this will be in production. And thanks again for watching, and I will see you another time.